So, hello friends, welcome to my YouTube channel. So today's topic is mm, stateful set and the headless service. Okay, so before coming to this headless service, we should focus on the deployment. Okay, so how the deployment works. Okay, so in the deployment, okay, in the deployment and in the stateful set. Okay, so they are almost the same. Okay, so they are almost the same, uh, but the difference is the that stateful set is used for the database applications. Okay, so stateful applications are nothing but the database application. Okay, let's say this is the stateful set YAML file. Okay, so this is same like deployment only. Okay, but here I am having the replicas. Okay, in the deployment set also you can give the replica, but this is the MySQL. Okay, so in stateless, if you delete the same pod, okay, if you delete the pod, okay, same pod will be coming. Okay, name of the pod will change. Okay, but in stateful, okay, if you delete the pod, okay, then same pod will come, and that too with the same data. Okay, so let's say if you have created the, let's say I will show you with the dot go to static path. Okay, cd uh, cd date and volume. Okay, so in deployment, when we are using the deployment, no, so that, okay, sorry, cd static host path. Okay, so host path is that your volume is creating on the node. Okay, so let's see, this is my deployment.yaml. Okay, so in this, when you are using the deployment through the uh, MySQL one, okay, so in that case, you are not having any replica. Okay, the reason I am showing you, okay, hyphen f dot, okay, kubectl, okay, so kubectl get pods. Okay, so one pod is getting created. Okay, that MySQL DB pod. Okay, so here that we see that this comes with the name create, and this MySQL pod is created with the name S7PM5. Okay, so uh, when you are deploying your pod with the deployment.ml, okay, so okay, ignore that error. Okay, so if I delete this pod, no, my kubectl, what is the name? It is S7PM5. Okay, kubectl delete pod and give this name. Okay, and if you run again, okay, if you apply the all the YAML files again in order to create the pod, okay, so this time it has created the pod with the new name. Okay, so what we have learned from this, when you are running the application with the deployment.ml file, okay, so that in that your pod is getting recreated. Okay, so it is best when you are using the stateless applications. Okay, uh, because that do not contain any data. Okay, in the stateless application, so that time it is good to use the deployment.ml. But here we have seen that your pod is getting changed, and your database, means your MySQL database name pod is also getting changed. So what if you have the let's say database endpoint name in this application, in this pod, and it is getting recreated, right? When you delete, means if if by chance this pod is getting deleted and that pod is deployed through the deployment.ml, and then it will be recreated again. So there will be change in the database endpoint name. Okay, so how the application will be connect to the database frame, then that will be an issue, right? So that is why we need to ensure the database state. Okay, so the in but in stateful. Okay, so if you delete the pod, the same data should come. Okay, so that's why we have to use the stateful set in the database application. You need to maintain the state, otherwise the data inconsistency will be there. And so you need to maintain the state. So why? Because you need to maintain the data, you need to persist the data, and for to persisting the data, we use the volumes. Okay, so we that's why volumes are mandatory in order to store the data. Okay, so whenever there is a replica in the stateful set, okay, so that time we should be using the cluster IP service. Okay, cluster IP equal to none. Okay, so if the stateful set is having multiple replicas, this is the condition for the cluster IP equal to none. Okay, so having replicas means creating multiple copies of the pod. Okay, so it is not good practice to create the multiple copies of the DB pods, but there is a logic here. Okay, I will tell you in the later. Okay, okay, so mm so we have seen how the deployment.yaml creates the new name. Creates the new name when we deleted the pod, right? We have seen that. So, mm, mm, mm. So only one replicas is there in this deployment.yaml. Okay, so here if the replica when it will create problem when there will be a replicas more than one. Okay, so here in this service means here we are having only one replica in the deployment.yaml. That time you can use it with the database application. Okay, that the condition is there that the replica should be one. And then in this case we should use the service. Okay, we can use this any service. But when the replicas are more than one, okay, then we should use the service is cluster IP equal to none. Okay, I will show you. Okay, so I will explain it through the paint. Okay, okay, so it is opening. So let's say we are considering one three-tier application. Okay, to better know the how the database application works. Okay, so let's say this is my web application, front end pod. Okay, web application pod. Okay, in that I am having, let's say, two pods. Okay, and here I am having the load balancer. Okay, this is my, let's say, load balancer. Okay, and this is my web pod. Okay, this is my web pod. Okay, that is the front end pod. Okay, so load balancer will place the request to any of the pod, right? Because it is not mean for to send any traffic to any particular pod, right? Let's say if we This can send traffic to this pod, or also the, okay, or this can send to this pod also. Okay, so it is not any, so till here it is okay. Okay, then we have the, let's say our, okay, change the color. Then we have the our application pod. Okay, let's say here is our business logic is there, right? Actual business logic is there. This is application pod. Okay, so here also we are having two pods. Okay, one, and that is, this is the second pod. Okay, so how this web pod will be communicating with the application pod, which service we need to use, because you have entered into the application. Okay, so this is the internal communication, web app to application pod. So which service will be using? So you need to use the that cluster IP service, right? Because it allows the communication between the internally between the pods. Okay, so once you are enter into the application, this is the internal part of the application, right? So this is my, okay, cluster IP. Okay, so this pod, okay, so this pod plays my request to this cluster IP. Okay, so and then cluster IP can place my request to any of the pod in the application, right? Either this pod or either this pod. Okay, so it will send the traffic to any of the pod which is coming from the web pod. Okay, it will send the traffic to any pod. Okay, so and this is my, let's say, database application over here. Okay, this is my, let's change the color. This is my database application. Okay, so I am considering that this is, okay, I am considering that this is deployed through the deployment.ml. Okay, deployment.ml, this application. Okay, considering my, I am having the only single pod is there. Okay, so this lot. So for in order to connect this app pod to the DB pod, okay, so which service I should be using? I should have to use the cluster IP, which is the interface between the web pod and the application pod, right? So I have to use this cluster IP only. Okay, cluster IP. Okay, so this application pod, okay, so the traffic which comes to this application pod, this can send request to cluster IP, right? And this cluster IP can send the traffic to this uh, the database pod, which is deployed through the deployment.ml. Okay, so this is okay. Okay, we are having only one pod. Okay, in the database application, in the database pod, which is deployed by to the deployment.ml. Okay, so cluster IP can send the traffic to. Here the point is that this can send to traffic to any of the means this cluster IP can send the traffic to any of the pod. Okay, so if you have three pods, it will send to any of the pods. Okay, that is the characteristics of the cluster IP, which is meant for the internal communication between the pods. Okay, so this is fair. Okay, because we are having only the DB pod as a only one. Okay, only one master is there. Okay, so it will act like as per expectation. It will not create any let's say data inconsistency. let's say if user is there, user is trying to register, okay, so the request will come to the web pod will send to the app pod, and app pod will be sent to the database, and the records will store get here that user registration, okay. So the next time it will come, it will flow like this, and it will come to again the DB pod. It will check, yes, the user is existed, because the database is our single pod, okay. So this is okay if your database is pod is only one. But what if you have the, let's say, multiple DB pods, right? Because in order to have the redundancy for the database pod, we should be creating the multiple pods. Okay, one should be master and other should be replica, right? So let's say that that case. Okay, so I will talking about that condition now. Okay, so copy this and paste this. Okay, so okay, okay, okay. So I am creating one more pod here. Let's say this is my master master pod, and this is my replica, right? So now with this architecture, okay. So let's say user requested, okay. Let's say user have registered, try to register, it will come to the web pod, then cluster IP will send to the any of the pod application pod, because application pod is a stateless, okay, it does not matter. And then the request will to the cluster IP, and cluster IP will send to the here the any of the pod, right? Because now two pods are there. Okay, so first time, let's say my user details are stored in the master database, okay, master database pod. Let's say that user comes again with this, the same user tries to request, okay, the same request will forward to the web pod to the app pod, then it will the cluster IP will now this cluster IP will send the request to the, let's say, the replica pod. So the replica pod will check, okay, this user is the new one, because the records were earlier, that user record stored in the master pod. Then the replica database replica pod will check, okay, this, because there will be no records for those user in the replica pod. Okay, so replica pod will say, okay, this is the new user. It will send the request back to the user communicating that the you are not registered. Okay, so that user already registered, then that user experience will not be good, because he has already registered earlier. So this is the uh, data inconsistency, right? Because although that user has registered, because in that user records are in the master DB, but replica is unaware of that, right? And this cluster IP can place a request to any of the master or replica, that it is designed to mean for to send any of the request to any of the pods, right? So this is the challenge here. Okay, this is you got the challenge now. What is the problem here? Because there is a data inconsistency is there when you are using the cluster IP with the deployment.yaml, right? So for this, you need to use the, so cluster IP can send traffic to any of the pod. So it is good to redirect the traffic to any of the MySQL pod. No, right? Because it will not check the data. So cluster IP is acting like a load balancer here. Okay, so at a one time it will records to the first MySQL pod, or it will send the second request to the let's say second MySQL pod. So this will lead to the data inconsistency. Then how we can connect application to database? Okay, not using any service. Okay, we are using here the cluster IP service. So we should be connecting directly DB using to credential. So how we can do that? Okay, so the for this there is a concept in uh, the headless service. Okay, so let's copy this and okay, sorry. Okay, what is happening, guys? I want this one. Okay, so let's say paint. Okay, so that's why I want to use means I there is a need for to use the stateful set. Okay, here I am considering the now. Okay, okay, okay. So let's say I am having the multiple replicas and this is deployed through the let's say so headless service. Okay, so whenever any request comes for the user, okay, so it will traverse through the web pod to application pod and then headless service. Okay, so this headless service, okay, so whenever multiple replicas of DB pods are coming, we should not use the deployment.ml. Okay, we should use the stateful set.ml file, right? So what will this headless service will do? It will always send the traffic to the master database only. Okay. Oh, sorry. It will means it will this application pod will be directly connecting to the database application through the endpoint. Okay, we will not use any service over here. Okay, so that will lead to the your request will always will go to the master database. Okay, so it will not create any let's say inconsistency because your request will always because you are using the headless service over here. Okay, your request will always route to the master database. Okay, so it is designed like that. Okay, so this is the concept of the headless service. Okay, so let's start with the practical. Okay, we'll see this with the practical. Delete this one. kubectl delete hyphen f. Okay, kubectl get parts. Okay, so no resource. Go to the headless service cd day 13, I guess. Yes. Okay, so here we are having four files, right? PV, PVC, and stateful set. Okay, so we have already checked those files that PV and PVC. Here we are having the replicas too of the stateful set. Okay, this is the MySQL database for the configuration, right? We are mounting on the. I will be coming with the session on this my secret. Okay, so root password is stored in this secret file. Okay, aware of this pv.ml, right? So pv.ml is creating the 5G of the space on the node itself. Okay. So this is the storage class and access mode, read write once. Your data will be stored in the MNPC. So it will claim the 5 GB of the actual storage which is used kubectl apply open here pv.ml. Okay, okay, so it is created. Check with the command kubectl get pv. Okay, so our PV is created with the 5 GB of capacity and storage class is manual and status is available. Okay, so let's now create the next one, that is PVC kubectl apply hyphen f PVC for ml. Okay, okay, check now the PVC kubectl get PVC. Okay, so the here status is the bound. Bound means this PVC has been bounded with the created PV, right? This PVC is bounded with this PV volume, right? Access mode, storage class. Okay, so till good it is okay. Now we will execute the stateful set. Okay, so you can kubectl, you can apply all the files, right? Because those are already created, so no worries. We can apply have dot. Okay, so it will create the stateful set. Okay, so we have given the two replicas, right, in the stateful set. So just check now whether those are created. Okay, so those are created now, right? MySQL 0 and MySQL 1, right? So stateful set. Okay, you can see that your naming convention here. Okay, there is no any random name here. These these are the uh, names given in my configuration file, MySQL 0 and MySQL 1. Okay, so it is following the some index here. Okay, stateful set follow the index MySQL 0, MySQL 1. Index 0 1 means MySQL 0 will always become your primary database. Okay, and MySQL 1 is the your read replica database. Okay, so my cluster IP should send traffic to MySQL 0. Okay, not 1, right? Headless service is nothing but we are directly calling from the application to the database. Okay, so in your application, database name will already been given there that MySQL 0 is my primary application, primary DB. Okay. So what if if MySQL 0 pod is deleted, okay, and stateful create pod with some other name, okay, my app will show the throw the error because there will be the change in the name of the MySQL pod, right? Because your MySQL 0 is written in your application where your business logic is there in the application pod, right? So that's why it is very mandatory to have the same name in order to avoid the data consistency. So same MySQL 0 will be created if it is deleted. Okay. So how it will get the same records? if we have if we create some data in this MySQL pod, okay, so we know that where if we deleted it MySQL 0, then it will create the same MySQL 0 and the date and with the same data. So how will get the same data records, from where it will get the data? It will be taken from the volumes, right? And that's why volumes is mandatory for the stateful set or the DB pods, right? So it will take the so I will do one thing now. I will delete this MySQL pod and we'll see whether we can get the same pod. Okay, kubectl delete pod MySQL dash 0. Okay, execute. Okay, so your pod is deleted and it will be creating with the see. It has created with the same name. Okay, age you can verify that is 4 seconds. Earlier it was 2 minutes 40 seconds, right? So same pod is being created because of the stateful set you are using, right? It will maintain your state. It will maintain your state. Whatever the records, whatever the data inside this pod, it will also be retained because we are using the stateful set, and it will fetch the data from the volume. In this case, we are using the node volume, so it will take the data from there. Okay, you can try means you can try inserting some data in this MySQL pod like we did in the previous session, and insert some records in this MySQL pod, MySQL 0 pod, and after inserting the records, after creating the tables and inserting some records, delete that pod, okay, MySQL 0, and let's see whether it is created and check whether it is created again or not. It will create it again, okay, and that too with the same records, okay. So that is the beauty of using this stateful set here, okay. So this is the uh, significance of this stateful set, okay. It will maintain your state of the pods, okay. So because this is very mandatory case when you are using the database, okay, database. This is very important condition. So how will means you have to maintain the state. Okay. So this is about the stateful set and the headless